But let's look at number 10. 10 is one that causes, I'll go ahead and say it, most students a little bit of trouble. That's okay. Remember guys, challenges are what make our brain grow and helps us get smarter. And so we need challenges, right? Trey, if you're in the weight room and you never are sore the next day, are you going to get bigger and get more fit for football? You got to put in the work. You got to get the challenges to improve and things like that. Okay, so really quickly, right? What is the first thing I would need to do with this left-hand expression to simplify it?
Distribute 3 times W and 9.
So I'd be left with 3W
Minus 27.
minus 27.
But both of them are divided by 5. So.
Okay. Notice the way that Amity said that. They're both being divided by 5, right? I can distribute that division. 3W divided by 5 minus...
27 divided by 5.
So are these equivalent?
Nope.
Notice, here's just 27, right, Zay? Here's 27 divided by 5. Those the same?
No.
So are they equivalent?
No.
No. Now I do want to take one quick second to point something out to you. Because I was thinking about it earlier today, and someone asked the question, and they're like, well, why do we distribute? So let's look at this really quickly to make sure it's clear why we distribute. When I do 3 times W minus 9, what is multiplication? Or one way to understand it?
Repeated addition.
Repeated addition, right? Which means I have W minus 9 plus
W minus 9.
W minus 9.
Plus W minus 9.
See, I have 3 of those W's minus 9s. So now I have W plus W plus W. How many W's is that?
3.
And then I have plus negative 9 plus negative 9 plus negative 9. How many negative 9s is that? 3. So can I have just done 3W plus negative 9 times 3?
Yeah.
That's just distribution. So it's not just a random thing that we just distribute. It's literally, hey, I have W minus 9 3 times, and so I have 3 W's, I have 3 negative 9s. That's why distribution works. We comfortable with those ideas? Okay, let's move forward then. So, without solving, determine if the 2 equations below have the same solution. Any predictions about whether these 2 equations would have the same solution? Amity?
It would.
Why
You
not?
have to distribute 3 times x and times 5, and in the second equation there's no 15.
There is no 15, right? So notice they're equal to the same thing. They're both equal to 35, right? But what about these expressions? They are not what?
Yeah.
They're not the same, so they're not equivalent, right? That's that term that means they're effectively the same. So they have they're equal to the same thing, but they don't have the same expressions. So the expressions are not equivalent, so the equations do not have the same solution. So expressions on, anyone want to guess what I mean by LHS? Left hand side. If I ever say LHS or RHS, left hand side of the equation, the right hand side of the equation. Nice easy abbreviation there. So expressions on the left hand side are not equivalent. So equations don't have the same solution. So I'm going to let that sink in for a second. And let you copy that down. Bless you. So, let's look at number 12 together. I'm going to give you 30 seconds once I stop. Circle the expressions that are equivalent. I want you to take 30 seconds and I want you to look at all 4 expressions and I want you to see if you think any of those 4 are equivalent to each other. You got 30 seconds. Go. In time. CJ, do you think any of those 4 expressions might be equivalent? Which ones? You can just make a guess or a prediction.
I can just
Which ones? Just say first, second, third, or fourth. Which 2? Or 3? Or all 4? I don't know. Any predictions? The second one? Which one do you think might be equivalent to the second one? The first one maybe? Okay. So we got the first and second is a vote. Trey? You don't think any of them are equivalent? Okay. Amity?
The second and the third one.
The second and the third?
both middle.
You think the 2 middle as well? We got some overlap there. All right. How can I determine if they're equivalent? What's the process to figure out if 2 expressions are equivalent?
You want to do like how you did number 10. You did 3W, subtract 27, and divide by 5.
And so I distributed that division. Is that what you're referring to? Okay.
Yeah.
So can I distribute my division here?
Yes, sir.
So CJ, how would I write this if I distribute that division?
3 numbers.
How would we write it? Not sure? CJ, we've done 3 of these now. If you're not sure, ask questions. I can't help you if you don't voice your concern. Okay? So pay attention, ask questions if it doesn't make sense. Trey?
Can I tell you my answer?
No. We'll get to your answer in just a second. Can you tell me how I distribute this division?
Yeah.
How?
Do 2 divided by 14.
I do 2 divided by 14?
14? Oh, 14. 14.
How about 4t divided by 2? Aren't we dividing by 2?
Yeah.
Okay. And what else?
Then do 10 divided by 2.
So we're distributing that division. I feel like I'm missing something. Don't forget that negative, okay? So now I need to simplify that further. So notice, CJ, right? Just like we distribute the multiplication, all I do is distribute the division by 2. Both 4t is being divided by 2, and 10 is being divided by 2. That's what I mean by distributing my division. Everything's getting divided by 2. You good with that? Okay. So what is 4t divided by 2?
2t.
2t minus 10 divided by 2?
5.
5. Okay, does that look identical to anything yet?
Nope.
Nope. All right, now what are you thinking, Trey? What was your answer?
I said no. I said none of them was equal at first.
Are you still thinking that though?
No.
What are you thinking now?
2 and 3.
Okay, so you're also agreeing 2 and 3?
Yeah.
Whew. CJ, before we simplify that second one, do you want to stand by your answer or do you want to jump on the bandwagon?
Yeah.
You're going to stand by your answer? Okay. So let's simplify. How would I simplify this?
4t. Yeah. 4t subtract 20. Subtract 10.
2t.
Oh, yeah, 2t.
First off, I would say I need to divide, don't I?
Yeah, divide those two. Divide, that'll give you.
So tell me, CJ, are these the same? So are they equivalent? No? Dang. Do you see anything that might be equivalent to number 2? Say again. Say it loud. I still can't hear you, but. Do y'all hear? Speak up, man. The third one. Come on, you hear how loud I get? You can speak up. You got a voice. Use it.
There you go, dude. Saying neither. It sounds like you were saying something between D and third.
Are those the same?
Yeah.
So the second and the third are equivalent. Those are the ones we should circle. Notice, some of us may already be seeing the equivalency right away, but if you just simplify, is it pretty easy to see if they're exactly the same or not?
Yeah.
Just simplify it. So let's talk through a couple of, or one of these at least. Let's look at number 13 first, all together. And I'm going to show you a couple of things I want you to be aware of. First off, there should be a minus here, x minus 2, and then a minus 2 here as well. I don't know why those negatives just aren't showing up, but they did. So let's go over this a little bit. What we talked about the last couple of days is the most efficient method to solve an equation, okay? I'm not going to say that it's the only way though. But let's go on a story, or let's read this equation as if it was a story. Trey, if I'm starting with this x, what's the first thing being done to that x?
Subtraction.
We're subtracting by 2, right? What am I doing to the x minus 2 then?
Multiplying.
Multiplying by?
4.
And then what are we doing to the 4 times x minus 2?
Divided.
Dividing by?
5.
Notice how that's the first, second, and third thing being done. So Amity, what's the first thing I should undo to solve this equation?
The division.
The division. I need us all to clearly hear this. This is the most efficient path. That's not the only path. But we talked through, if you can read the story that is there, then you can undo it using your inverses. So I need to undo this division. How would I undo the division by 5?
Multiplication.
Multiplication by 5. Because what is 5 divided by 5? 1, thank you. We all get with 5 divided by 5 is 1.
Oh.
Yes?
Oh,
Okay.
I was gonna say 25.
Say again.
So I was going to say 25, but we're not opposite.
But notice that's why we're dividing by this 5, right? We're multiplying to cancel out that division, but I can do it as 5 divided by 5, and that makes it a 1. So on the left-hand side of the equation, what am I left with? What's 1 times 4 times x minus 2?
4 times x minus 2.
Right, it's just being multiplied by 1. So is that equal to 20? Is 4 times x minus 2 equal to 20?
No,
No.
Why not?
because you have to multiply 5 to 20.
Oh, I need to multiply the 20 by 5 as well? Why do I need to multiply by 5 over here?
Because you can't leave nothing out.
Okay, look, we need a little bit more than just that.
Equality.
The properties of equality, right? Whatever I do to one side, I have to do to the other to maintain its equality. The fact that it's still equal. Specifically, and I want to start building this language in, does anyone know what we would call this property of equality?
Multiplicative.
The multiplicative property of equality, right? We're multiplying, so there we go. Mathematicians are not original. Everything they name has a reason to it, just about. So, the next thing I'm looking at, okay, so I'm still looking at this and I see x minus 2, and then I'm multiplying by 4, so what's the next thing I need to undo?
You need to do addition.
I'm going to take care of this addition first. What's the first thing happening to this x? It's being subtracted by 2. Then what's happening? It's being multiplied by 4. So what's the first thing I need to undo?
Multiplication.
The multiplication by 4, right? I need you to recognize that the last thing being done is the first thing I need to undo. So how am I going to undo that multiplication by 4? Divide by,
4.
so I'm going to use that reciprocal.
Yes.
What is 4 divided by 4? 1. So I need to use my multiplicative property of equality over here as well. And so 1 times x minus 2 is just
0 1
1 times x minus 2 is?
1 minus 6.
Can't put x minus 2 in that calculator. It won't help you. You can't put the x minus 2 in that calculator. Yo, what's 1 times 5?
5. Oh, 2, negative 2.
Not just that. What's 1 times 17?
17.
So what is going to be 1 times x minus 2?
X minus 2.
Right? The 1 is what I needed so that when I multiply, I'm just left with x minus 2. 20 times 1?
20 times 1 is 20.
Divided by 4?
Divided by 4, it would be 5.
Thank you. What's the last step now to solve for x? Addition by
2.
2.
So 2 plus 5.
Well, first off, what's negative 2 plus 2?
Negative 2 plus 2 is 2. No.
4.
Not 4.
Negative. No. Negative 4?
Put negative 2 plus 2 in that calculator.
0.
Thank you.
Oh, I forgot to go up with the plus.
It's the inverse, right?
Yes, sir.
It's going to create that 0. By the way, what is this property of equality?
Addition rate.
Well, those are rates of change and things like that. No, this is a property of equality. What did I do?
Common ratio.
No, it's a property of equality, not a rate of change. What operation am I doing? Don't look over there. That's the wrong thing to look at, Zay. That's functions. We're solving equations. What did I just do?
Addition.
Addition. So it would be the additive property of equality. What you did is the type of property of equality. I added, so it's the additive or addition. Make sense? But Zay, I need you to understand. That was for functions. That was for rates of change. That's not for solving equations. Yeah, the only reason I still have it up is because that's what my algebraic connection kids are working through right now. So x is equal to?
7.
Okay. Now I want to put a pause on this for a second. This is the most efficient path, just using our inverse operations. However, is it legal for me to distribute here?
Yes.
Why is it legal for me to distribute?
Good.
What do you know about this expression and this expression? Are they effectively the same?
No.
Why not?
That's 2.
4 times x minus 2, if I distribute, I get 4x. 4 times negative 2 is? They're the same, right? So those expressions are equivalent. So I created an equivalent expression, so is that okay?
Yes.
Yes. Now when I read this equation story, what's the first thing happening to that x?
It's being multiplied.
Being multiplied by 4. Then?
Subtracted.
Subtracted by 8. Then?
Divided by 5.
So still the first thing I'm going to do is the last thing that's being done. So to undo the division by 5, I'm going to multiply by 5. 5 divided by 5 is 1. And then what's 1 times 4x minus 8?
4x minus 8.
20 times 5? 100? Now notice, I created an equivalent expression, so things are going to slightly change, but not much. What's the first thing happening to this x?
Being multiplied.
Being multiplied by 4. Then we are
5.
subtracting 8.
Subtracted.
So what's the first thing I now need to undo?
Multiplication.
Is that the last thing being done?
No.
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 You You gotta add.
The last thing that's being done is that subtraction by 8 right now. So that inverse would be
This.
plus 8. Negative 8 plus 8?
0.
100 plus 8?
108.
I made a mistake somewhere. Did I?
Where?
Oh, guys, I made a mistake right here. What was 20 times 5?
20 times 5 is
100.
oh,
And so I should have done 100 divided by 4, which would be 25. 25 plus 2 would be 27. Sorry for making that mistake earlier. So then I get 4x is equal to 108. Now what do I need to undo? That's the only thing left, right? How am I going to undo that multiplication?
Division.
Division by 4. Or I'm going to use that reciprocal,
1 over 4.
1 divided by 4. Right, so I'm dividing by 4 right now. Notice I don't say 1 over 4, right? Multiplying by 4, so now I'm dividing by 4.
Divided by 4.
Anyone want to take a guess
Whoa.
what 108 divided by 4 is?
108 divided by 4 is 27.
Yeah. Notice, this is the using the inverses and undoing the order that's been done. But is it legal to create equivalent expressions?
Yes.
Will it yield the same answer eventually?
Yes.
Yes.
Hey, little Chris. Well, I'm just gonna let y'all know today is one of them days that I can't talk. But anyways, do you need a mask? The PCSO will be selling a mask this afternoon for $10 each. This mask will be great for our away games. The equestrian or horseback riding club and team will have an invest meeting for new members after school on Thursday,
Now,
October 8th.
Let me go ahead and
The
say
meeting
this.
will be
Good, I
held
assume
in
none
Ms.
of y'all are
GB's
gonna be
room
engaged in any
on
of
the
this
English
stuff. Is that
hallway
fair?
in room 310.
Okay.
See Ms. GB for more
I would
details.
still personally, most of the time, say, hey, X
If you
be
signed up for
divided
the
by
voting
5
team and
first.
you did not
So
attend
this
the
is the
meeting,
first thing.
please see Coach Hatton in the library
This is the second
at some
thing.
point today.
And then
All
this is the
newcomers should
third.
turn in their
So that
$15
times 4 is what
for
I'm going to
late
undo
fees this
first.
week.
Because
If you want to be
if
a
I were to
homecoming man,
distribute
visit
here,
the
I would get
hillcristhigh.tcss.net
4 times X
and
divided
click
by
the link to
5.
the left. Complete the
minus
application by
8.
Friday, October
I just
9th.
don't want to deal
Payment
with
can be
that
made
fraction.
online or by
Does that
bringing the
make
check
sense?
to the office before the deadline.
So,
Visuals are
you can
hosting a
always
t-shirt
create an
fundraiser and
equivalent
selling comfort color
expression.
shirts for $20.
I'm not
If
saying
you would
that
like to
you
purchase
can't.
one, see a
I
visual
would
girl
personally
or Ms.
recommend
to order.
identifying what's being done though and
Grade
then undo
10
it
through 2.
from
Students
the
who want to take
outside
dual
in.
enrollment in the spring
That's
need to
what I
apply
would
to Sheffield
recommend.
Online,
But I
complete
do
the
want
online
you
dual
aware,
enrollment
be aware that
form.
you can do equivalent expressions.
Until November, scholarships
Tonight,
are
homework.
available. Students must have a minimum GPA
14
of 2.0
and
for technical
15.
courses and
Okay.
2.5 for academic courses.
I'm not going to show you the
Thank
actual
you.
homework page because we didn't get as far as I thought we would. So 14 and 15, and please hear me very clearly, you need to do constant, variable, and coefficient from the vocab sheet. All of you already did those last 4 from last night. So tonight I need you to do constant, variable, and coefficient. To make sure it makes a little bit more sense, I do want to point this out. Does anyone have an example of an expression that we can write? Hopefully we do after today. Does anyone know an expression or an example of an expression?
You need to make up one?
Huh? You can make one up. But you should already have some on the other side of that. Is an expression one of the words there? Did we come up with an example?
What
Oh,
expression? What expression?
I thought we just put a worksheet.
Oh, we can. Okay, but is that an example of an expression?
Yeah.
There's no equal sign, so yes. What is the coefficient for this expression?
You said constant, variable, and what else?
Coefficient.
Coefficient.
Huh? Yes. Really quickly, guys, come on. What is the coefficient in this expression? The 4. The coefficient is the thing being multiplied by your variable. And then what would this negative 5 be then? That'd be a constant. I just wanted to go over that quickly to make sure that you understood that well for when you did your vocab. We will wrap up and go over numbers 14 and 15 tomorrow. Okay, hold on to it because we'll go over it in class. Boy, day, buddy. Great. Looks like everything's okay with your calculator. I hope. Be careful with your technology.
Oh, my bad, my bad.